Developers treat search as a black box. They throw everything in a vector database and hope something good comes out of it. They also throw all ranking signals into one big ML model and hope it makes something decent. And you don't want to create this witch's cauldron where you throw all your ingredients in and hope for a magic potion. It might work, but when it does, you won't know why. It's difficult to debug and adjust. You won't know which, for example, ranking signal actually delivered the important signal. And if something goes wrong, you need to retrain the entire model and you can pinpoint why it went wrong. And you want the exact opposite. You want layers of tools or techniques aligned in a graph that you can tune, debug, and update in isolation. For ranking, this might look something like this. You have like a top layer of personalization with user-specific adjustments. So for example, this only adjusts the result positions of the different search results. In the middle layer, you might have something like signal boosting. So popular items are within the specific query, specific terms are boosted, and this might also happen based on some user behavior data. And the base layer might be a generalized ranking algorithm, which is like your core relevance scoring based on similarity, but also like your TF-IDF scores. And through this, we basically can control each layer and can tune it independently of the others, and also enable and disable specific components, which becomes very interesting when you actually want to adjust them based on the user query and pipe them through different paths through the graph you have. And it allows you also to easier debug why something went wrong, because you can pinpoint, okay, where was this result actually like boosted up or ranked higher. So it actually went to the user, and it also gives you the ability to update each layer without affecting the others. So it makes it easier to A/B test specific components. And this reflects like a broader principle in software engineering where you prefer clear and separated components over monolithic black boxes. It's just the same as you wouldn't throw all your application code into like one giant function. So you shouldn't throw all your ranking signals into one giant model. And you shouldn't throw all your hopes into a vector database or an embedding model by OpenAI. And today we are continuing our series on search. We are talking to Trey Grainger, the author of AI-powered search, and we look at the different techniques with modern search engines and recommendation systems and how you can bind them. And Trey brings a wealth of experience from his different search positions with Solr, Elasticsearch, and also now from his own shop, Search Kernel. Let's do it.
I think RAG is a bad acronym. I think GAR is also a bad acronym, only because it goes both ways. And so I think that it's more of a synthesis of using retrieval to make generative models better, and then using generative models to make retrieval better. So I think it's actually more that retrieval's in the middle. You use generative models to help interpret queries and understand them. You then to better understand them. And then once you've gotten the results, you also take that to improve the output of the generative model. So I think it's GARRAG or RAGAR if we wanted to start to combine them together. But I don't know. I think it's more important that people understand the concept and how to put these things together than get hung up on particular acronyms.
Yeah, I always think of like your search system in the end rather as a feature pipeline for my generative model, as opposed to like just retrieval. How do you see it? Do you think like how I think about it is wrong?
I think of whether it's search or generative AI, I think of all of these systems as nonlinear pipelines. And so for me, if I think of, I'm just going to talk about retrieval for a second. If I look at a typical information retrieval architecture, usually there's a query intent aspect of it. You take the query intent, you run a search to find results, probably over request, and then usually there's some sort of a re-ranking phase. But that's a very overly simplified version of what we're doing, because often you will try to interpret query intent, maybe take that, go out and look up some more information to better understand query intent. And that might include going to your index and finding what's there. And so you refine the query intent and you request information potentially multiple times. You get results back, you do re-ranking, and then potentially, if it's more of an agentic framework, you might actually return results to a generative model that then determines, I actually want to explore this further. And you continue on, and maybe you repeat that process multiple times. Where we are and where we're going, I think, not thinking about it as retrieval as 3 steps, interpret intent, get results, and re-rank, but think of it as that is a sequence that happens in a larger pipeline, and that pipeline might be linear or it might be nonlinear. And then I think to your actual question, which was, how do you think of retrieval in the context of generative AI? It's the same kind of thing. The reason we use retrieval when we're working with generative AI is because a generative AI model, these LLMs will take your query, your request, whatever you're asking for. They will then try to interpret them. And without access to up-to-date information, without access to correct information, they will generate a response from their highly compressed understanding of the world. And so we use retrieval to augment them with information. But so that first phase, though, which is the interpretation of the query, is boosted by the second page, which is the retrieval. But then all of that gets pumped back into the generative model to summarize, which is used in the generative model again. So in a lot of ways, I think of retrieval as sandwiched in between the generative AI, where there's generative AI at the beginning and at the end, and retrieval in the middle. But again, you can always go back to retrieval multiple times. You can try to assess and summarize multiple times. It's better to just think of these as almost 2 different techniques that are it's almost like you're playing a game of ping pong back and forth, where the generative model says, hey, I need some information. The information comes back, and it just keeps going back and forth until a sufficient answer is determined.
And this, in the end, it's like really use case dependent, but in the end, it's like a graph, which isn't the traditional graphs we see in like data processing, like a DAG, which is acyclic, but we can branch, we can do really elaborate loops as well and go back. And basically your use case should inform what actions do you take. Like in e-commerce, when I have to be really fast, I probably can't do many loops. But in something like report generation at the moment is a really hot topic. I can do probably as many loops as I like and focus more on like really getting the information down.
Yeah, for sure. Yeah, I think in search in particular, one of the key aspects is people expect it to be fast. So a lot of the time, even though you could find a way better answer with 10 minutes of processing, a lot of times you have to optimize things to get down to milliseconds of latency. So it's definitely a lot of trade-offs there.
Yeah, but I think like search has a real renaissance at the moment because it's now being used in way more context than the traditional search was used. Like we are going way past like website search, web search, but we're using it to feed the right information into the LLM so we can actually perform actions or do whatever we want.
Yeah, for sure. And I think, I don't know if we've crossed the threshold. We may have already, but go back a couple of years, and if you think of the big web search engines, Google, Bing, mostly Google, Baidu, et cetera, I like to think of the web search engines as basically a giant cache of the internet, right? You could take these generative models and you could have them figure out what you're asking for and then go crawl the entire web to find the information and process it with web crawling, all of that, and then return a result. But it might take you 10 years to go through the entire internet to find the right results. Whereas what the search engine does is it serves as a cache of knowledge, a cache of information that the generative models are basically relying on to get all of that data in milliseconds. So they cache it and make it very efficient to find the most relevant information to use. And so that's why search engines are so well paired with generative AI for RAG, because they provide that quick access to the data. So I think the reason there's this renaissance is because we need the data for these generative models. And we're probably close to, if we haven't already exceeded the point where the number of requests going to these search engines, which were originally designed for humans, they're probably very soon, if we're not already there, most of the requests are going to be going to the generative models. Bots already make a lot of the requests, but I see a future where humans are the vast minority of the requests going to search engines.
Yeah. And at the moment, I see two different camps like talking on the rec space. One is like really the AI side, which is coming from LLMs and have discovered like RAG and barely even retrieval. And then you have the search side, which is coming with all their like methods for actually figuring out retrieval and more old school techniques, which are very well thought through. What do you think are the misconceptions of both camps when it comes to AI powered search in this new generation?
Yeah, no, that's a great question. So I come from more of the search camp, so I'm going to start with that answer. What I see, so I'm going to just do an analogy to start. So I got my start in the information retrieval space migrating to Apache Solr when Solr was very early. And after Apache Solr, Elasticsearch came along and had some things that were better designed for that era, and Elasticsearch started taking market share. But they did something very smart and very interesting, which is it's not like they were coming and taking away all of the people using Solr. What they did instead is they used logs. They used Logstash and Kibana to make a really useful tool that to solve a problem everybody had, which is, hey, I've got a ton of log data and I need to be able to analyze it and pull it together and analyze it. So by doing that, they actually opened the door for an entire new genre of search people. They brought in all sorts of DevOps people, all sorts of people that really needed to do log search, got in the door, got tons of installations. And then those people, once they had used the tool for a while, started to realize, wait a minute, I can do way more than just log search with this. I can search on all kinds of data. I can build all sorts of products on top of it. And by doing that, the number of people in search and information retrieval just exploded once they developed those skills. I see a very similar thing happening now with generative AI. So people start to build their companies, their startups. They're trying to build generative AI-based products. Once they start, they realize, hey, these things hallucinate. They don't always give me the right results. I need to supplement this using RAG. So they hear the term RAG. They don't exactly know what it is, but what they hear is, oh, I need to plug in a vector database. I need to take my data. I need to encode it with a transformer. I put my embeddings in the vector database, and now my system can magically somehow take the queries, get data from the vector database, and use that to supplement the results. So they do this. They maybe use some off-the-shelf tool and LangChain, LlamaIndex, something like that. And once they've done it, they start to realize, wow, this is like magic. Somehow, miraculously, my generative AI now has access to real, live, up-to-date information. And it looks like magic some of the time. The rest of the time, they get really weird results because the data that's coming back from the vector database for the retrieval part of RAG isn't the right data. Out of all the documents, maybe they got the wrong ones. And so then they very quickly start to come and look at why that's happening. And what they end up doing is they meander, they start doing some research, and then they open this door. And when they open the door to information retrieval, they start to look inside. They see all of the folks who come from an information retrieval background waving, saying, hi, welcome to the club. Here is all of our knowledge about all these techniques and tools. And some of them say, wow, that's amazing, and they dive in. And some of them say, oh, and they shut the door and continue on their way to solve other problems. So I think that's my sort of little analogy here, which is I think there is a renaissance in information retrieval and search driven by the generative AI capabilities. But I think that very quickly people are realizing that the R part of RAG is really the hard part and the part that takes years and years to get right if that part is critical to the system. And I think the misconception is that, oh, hey, for RAG, I can just plug in a vector database and a couple of libraries, and a day or two later, everything's magically working and I'm off to solve the next problem. Because search and information retrieval is one of those problems that you never really solve. You get it good enough and quit, or you find so much value in it, you just continue investing to constantly make it better. On the flip side, I think misconceptions on the search side of things, I think there's a lot of people who have been in search for a while who know all of the old school techniques, lexical search, stemming, lemmatization, field boosting, using NLP libraries to do parts of speech analysis and boosting. There's all these techniques that sometimes they're still useful. But I will definitely say over the last 2 to 3 years, I've probably thrown out about 25 to 30% of all the tools and techniques that I used to use just because they're not relevant anymore. The other 60 to 70% is still highly relevant, and those things still need to be done. But there's a lot of things that we've just got better tools now. And I think a lot of people maybe are a little afraid to embrace those new tools because they've got the way they've always done things. But everybody's different.
Yeah. What are the parts you have thrown away and that you would recommend people throw away from traditional search?
It's a good question. I should preface this by saying every problem is different. If I was tasked with, hey, I've got 1,000 documents and their recipes, and I'm trying to put them in a search engine so I can quickly find the ingredients for my recipe, I would say, okay, let's load those in Solr, Elasticsearch, OpenSearch. Let's do lexical search and let's call it a day, because that's not a hard problem to solve and you're looking for specific ingredients, and the old school techniques are more than sufficient. You don't need a vector database. You don't need embeddings. You don't need a transformer. It's overkill. I should caveat this with saying, depending on what you're building, the old school techniques might be fast, cheap, efficient, and even do a better job. That being said, for your larger use cases, your e-commerce use cases, your more sophisticated enterprise search use cases across the board, I think a lot of the NLP techniques, specifically things that you would use NLP libraries for, OpenNLP, things like that, where you're doing parts of speech detection and trying to say, well, I'm going to match on the nouns or I'm going to match on the verbs. I think those are basically not as useful anymore. I think if you've got the ability to leverage an LLM, it's going to do a way better job at understanding the entire context and picking out which words and phrases matter. So those are just a waste of time, in my view, in most cases. I also think that we're entering a phase now where document interpretation and understanding and enrichment can be, in many cases, done way better by language models than by some of the old school pipelines that we would have built. We've got things like OCR, optical character recognition, for reading PDFs and documents very rapidly being replaced by things like vision language models. So if you use something like ColPally, then you can even take the entire PDF or document, pass it into the language model, have it interpret it and turn it into a vector. And all of those in between steps of parsing and tokenizing and OCR and all of that stuff just goes out the window, because when you compare its efficacy to what you get with a vision language model, the vision language model just blows it out of the water. So you're wasting a lot of time doing things that get you worse results than if you just didn't spend the time at all. So those are some examples, I think.
Yeah. And you mentioned you have to pick like the right tools, and you have to take a lot from the different fields. One we haven't mentioned yet, which is like a major topic of your book as well, is recommendation systems. Mm-hmm. I want to know what you actually took from recommendation systems and brought into your search system. But first, like, how do recommendation systems differ from the search systems, and where do they overlap?
Yeah, it's a great question. So I take a slightly different view than some people, but my perspective is that there's fundamentally, at least conceptually, no difference between a search engine and a recommendation engine. And what I mean by that is, when you have a search engine, just think of a traditional search engine, like keyword search, even vector search at this point. Somebody types in some keywords, a question, some text, maybe it's an image, but let's just go with text for now. They type in some text, and that text is the context by which they want to match documents and rank those documents coming back from the match. Assuming for now we're just getting documents back, nothing more sophisticated. The context is keywords, and you get matched results back. When I have a pure recommendation engine, let's say it's collaborative filtering based, meaning it's based upon the interactions of users with products and their behavior. What do I have? The context that I have is the behaviors of the user, maybe a profile of the user. It's things I know about the user. I take that context, I pass it to a matching engine to match and rank and return results. So if you conceptually abstract search engines and recommendation engines up one level, they're both engines that take context, they match results, and they rank the results. And you can say, well, yeah, you're oversimplifying it. Why? But they have different purposes, right? Yes and no. If I think of it not as two different types of technologies, but I think of it as one type of technology, a matching and ranking engine that takes in context, then what I can do is I can say, what about all the space in between? So if I move from a pure search engine that the context is only explicitly entered by the user at query time, and I say, yeah, but I've got some user context as well. So why don't I use that user context to change the way that I match and rank the results? That's where you get to personalized search. And so you could think of, for example, let's say I've got a restaurant search engine and I'm in New York and I search for hamburger. I would be pretty upset if my search engine returned me hamburger stores in Atlanta and Chicago and London, because I'm in New York. The search engine should hopefully know about me and where I am, if nothing else based upon my IP address. And every restaurant search engine will do that. But that's an example of personalized search. It's taking information you know about the user. In this case, it's just a location from an IP address, and using that to augment how you adjust the query. That's a pretty simple example. On the flip side, if I go from pure recommendations and I say, let me augment these with user context that they're typing in now. So the user could go in and say, hey, I don't want to include this document that I looked at before. Take that out of my recommendation algorithm. Oh, also, I would like to filter down to these results. Oh, also, let me add some keywords in and make sure I fine tune my recommendations so they target those results. That's an example of, I would call it just augmented recommendations. It's not pure recommendations just from user context. You're also taking explicit input. And so this notion of getting some input explicitly from the user, usually keywords, and getting some information based upon user behavior and what you know about the user allows you to do very interesting things in the middle. And I would say, and we can talk about this more if you want to dive in, but being able to take user behaviors, user searches, their queries, their clicks, maybe products they've purchased, taking those signals and using those to generate embeddings that represent what they're interested in, and then pairing those with what the user is searching in terms of keywords and what that means, you actually get to this almost sweet spot in the middle where you've got as much coming from user understanding as you have coming from their explicit intent, and then you can marry those in different ways. And so what I would say is, to me, their search and recommendations are fundamentally the same problem. They're just using different contexts. And what I really like to do is think of the entire spectrum, and depending upon what you're building, target the appropriate level of balance between the explicit context and the user context.
Yeah, and we will double click soon, but I think we have the perfect precursor or contextualization for the 3 buckets of relevance in search system, which you go into in your books. Can you maybe explain like the 3 buckets of relevance and the different search techniques that fall into the different buckets and also the intersections between buckets?
Sure. Yeah, happy to. Yeah, highly related to the last topic. One of the fundamental questions when someone's approaching search, or when you're doing retrieval augmentation, you're thinking about how to think about the retrieval piece of it, is this concept of relevance. And going back decades and decades within search and information retrieval, we define relevance as matching the user's or meeting the user's information need. Basically, if you can understand what the user is looking for and return that, then you've succeeded at providing relevant results. And so the question is, what is the user intent? And to me, there's 3 categories or I would say 3 contexts that are really important for understanding intent. One of those is the content context. One of those is the user context. And one of those is the domain context. And so if you can mentally think of this Venn diagram with 3 concentric circles, in the content context, if I'm looking purely at the content and nothing else, I don't care about the user behavior, I don't care about the domain, that's where we've got traditional keyword search. Type in some keywords, I match on those keywords, and that's it. No other context taken into consideration. Like we just talked about, if I look purely at the user, that's where I'm in recommendations, right? It's collaborative recommendations, and I'm just literally looking at what's this user's behavior, what items have they clicked on, what items have other users clicked on, and it's all behavior-based. And so that's pure recommendations. And then if you look at the intersection of those, that's where you get personalized search, which we just talked about, and all of the things you can do with combining those 2 contexts together. But there's the third category, which is the domain context. And so if you overlay the domain context and look at the intersections there, content is, what's in my engine, the behavior we talked about, and then the domain context is what you understand about your business, your domain, the topics. If it's say you have a paint store, it understands colors, it understands relationships of colors, it understands enamel versus I don't know paint that well, but all the different things you would need to know about paint. If it's in the pharmaceutical industry, you would have a very different understanding of that industry. And if you look at just the domain context, absent of the content you have and absent of the user context, just the domain context, that's where you would have a knowledge graph. So people are building ontologies, taxonomies, all those relationships. You can just roll those up and say, collectively, those go in and make a knowledge graph. That is a modeling of your domain, independent of your content and independent of your users. And so then you look at the intersections. Okay, well, if I have a knowledge graph, that's my context, and I look at the intersection of that with my content, what do I have? In that case, it's semantic search. So when you marry the domain understanding, all the words, terminology, phrases, relationships, with the content that you actually have, you're doing semantic search. And so there's multiple techniques for that. There's just leveraging embeddings with transformers, especially if they've been fine-tuned to your domain. There's also lots of semantic search techniques we've been using for a decade or more around sparse lexical types of matching, where you're understanding the meaning of words, you're expanding the query. If someone says barbecue or top barbecue near Atlanta, then you can understand that near Atlanta is a location, and then you can filter down to a radius and do some query rewriting to understand those things. That doesn't require a transformer. It's one way of doing semantic search. So that's the intersection there. Zooming back out, content understanding, user understanding, and domain understanding. And if you intersect content and user, you've got personalized search. If you intersect the content understanding and the domain understanding, you've got semantic search. And there's the third intersection, which is less interesting. But if you look at all of them together, the very center where all of those contexts overlap, content, user, and domain, is where you really get at user intent. And to me, anytime you're building a search system, whether it's traditional search, whether it's RAG for generative AI, you need to have all three of those contexts in order to effectively get the most relevant results to solve the problem.
Yeah. And do you think like all of these three contexts have an impact across like the entire retrieval pipeline? And this is basically like the query intent, retrieval, re-ranking, and now like also the like generation part, which is coming closer and closer. Do you think like each one of those should have a place in each of these components?
I don't want to say absolutely always, but in general, yes. One of the things, just zooming out a little bit, that I find the most challenging with the current era we're in, which is lots of focus on vector databases, lots of focus on transformer-based encoding. Most of those encodings are text-based, or even if there's images and it's multimodal, you might get you'll get the content context. You might get the domain context if it's general or if you fine-tuned to your data, but almost none of these systems are getting the user context because it's hard. Because in order to get the user context and understand your users, you have to collect their queries, you have to collect their clicks, you have to collect what they purchase and act on. And if you do it well, you actually need to collect the things that they don't click on as well. You need to know what they saw but didn't click on to know what they looked over. And so there's a whole realm of building click models to try to train some of these things, which we could talk about. But the reality is the reason that people are using these RAG platforms, and I would say almost formulaically, these libraries that sort of give you out of the box RAG, is because it's easy. Not that LLMs as a concept are easy, they're very sophisticated, but being able to write a few lines of code, encode my text using some off-the-shelf model, put it in a vector database, query it, and get results that look somewhat like magic is easy for someone to implement. Adding in the user context and doing all this collection of user behavior and processing it is a lot of work. Therefore, not only do most people not do it, most people I've talked to who are working on startups in this space don't even know about it. They don't even know to ask the question of how should I be incorporating my user behavior into the system.
Yeah. And I think I will be just rattling off like a few techniques as I understand it. Domain understanding you can use across the board. For example, you can even use graph embeddings for your search. You can use them for re-ranking by filtering the results and looking at the different entities which are used, for example. In content should be very clear. But I think like personalization is probably, or the like user bucket is the most difficult, especially because architectural wise, it involves a lot of different components as well, from the client to basically your database. Yeah. If you actually think about it, like from a systems perspective, what are the different components which are actually necessary to implement this user understanding or user loop completely?
Yeah. Okay, I'll start with, let's say you were going to go build this tomorrow. What would you need to do? Then I'll get into how you apply it. First thing, as you mentioned, there's a user interface component, right? The user's interacting, they're clicking on things, what have you. You need to collect that user interaction. So what does that mean? Probably some sort of a JavaScript library. There's stuff like Snowplow out there you can use to collect user behavior in the browser and pass it to the back end. But what you ultimately want to be collecting is every query the user runs, the results in the order they were returned to the user, whatever the user clicks on, and then any other subsequent user signals like purchases, add to carts, if you can get it, things like returns or posted a bad comment on a review site or what have you. Any signals, behavior you can get from the user about how they liked and interacted with the product as a result of that query is fair game for as a signal. So you have to collect those things, know what to collect, know how to format them, know where to save them. Once you've done that, and that's like step one is collect the data. Once you've built that though, which is not trivial, but it's doable. And in my book, I've got a whole section on the right format to store it in and how to save it. Also, the OpenSearch project recently built a add-on, maybe it's going to be part of the core at some point, called User Behavior Insights, which is basically a schema for how to collect this data appropriately. And they've open sourced it, and I think they even have implementations for some other engines like Solar. So I think they're trying to more create a standard for the industry in terms of how to do this. But regardless of whether you build something bespoke or try to leverage something that's more standardized, you have to collect the data. But then once you've done it, you have the ability to build all kinds of models based upon that. So some of them are personalization based upon a particular user and what they've interacted with. You can look at you can look at all the products they interacted with and average those vectors together and then use that as something that sort of represents that user's interests. And then the next time they run a search, you can boost it up or down a little bit based upon interpreting that vector in the context of the user's vector. That's one way to do it. Another way is just to generate recommendations and use those to boost results. You can apply guardrails where you can cluster all of your documents together. Say if it's e-commerce, you cluster it into maybe 100 categories. And then from there, you can personalize within those categories when they search for things within those categories. So as an example, if I've got this one in the book, but if somebody goes and searches for a Hello Kitty water bottle or a Hello Kitty plush toy or something like that, and then they search for a black GE electric razor for their face, and then maybe they go search for a stainless steel range or stove or something like that. And then their next search, they search for microwave. That user's probably not looking to see a Hello Kitty microwave. That thing does actually exist in my sample data set. They're probably not wanting a Hello Kitty microwave. They happened to Hello Kitty and they wanted a water bottle or a plush toy, but when they looked for appliances, they were looking for a stainless steel range, which means probably they want to see a stainless steel microwave. Similarly, if they search for a GE razor and they search for a stainless steel Samsung range, they're probably not looking for a GE microwave just because they got a GE razor. Because the situation is there's two very different categories. And so you have to make sure that when you're personalizing, you don't over-personalize, because there's no better way to make your users really angry with you than to stick them in a bucket and get them stuck in that bucket, which is not their actual intent. So personalization is something you have to be careful about.
So basically, the cluster would allow me to basically cluster the behavior or whatever he did and the results that were returned into certain areas.
Yep.
And when the cluster is too divergent from the current query, I can basically decide to exclude the results which are also in this cluster. The example being like the Hello Kitty microwave.
Yeah, well, and in particular, the way I usually build this out is if I'm focused on personalization, say a user runs a search, I generate an embedding, I do my dense vector search to find results, I will get a personalization vector for that user that has all of their relevant behavior. But what I'll do is I'll filter that set of items down to only items that are within the cluster of the user's query, or maybe like the 5 or 10 nearest neighbors, depending upon how many clusters I have. So I can find either in the exact cluster or in a very nearby cluster. And then I'll only personalize if I know that the behaviors are within the same category as the kind of query that came in. That makes sense.
So basically you contrast the result sets. You run a regular search, for example, you run the personalized search, so basically like a recommendation system with a personalization vector, and you compare the results sets, and when there is no overlap or a very low Jacquard distance, you actually tend to disregard the personalization results.
Yeah, so I actually, for my personalization vector, I'm actually filtering out the behaviors that are not in a cluster that is similar to my query before I even apply the personalization.
Oh, interesting.
So think of it like I'm doing on-the-fly recommendations, and I'm choosing the data points that I'm using for the recommendations based upon the user's query and filtering down to only behaviors that are similar to the user's query or in similar categories as the results of the user's query. So it's what you said, but I'm actually doing the filtering at pre-matching and ranking. I'm doing it up front to filter down the behaviors I'm going to use to personalize.
Yeah. And I think this already leads us into the next question. How do you actually handle the conflicting signals between the other buckets as well? So basically, if there is a conflict in the domain and the user, or domain and the content.
Yeah, it's a very good question. There's a couple of different approaches to this. Let me lay some groundwork here and maybe give a few concepts and terms before I answer this. I mentioned signals and collecting the signals and that you can use them for personalization. That's one way to use them. I tend to think of ranking algorithms in a couple of buckets. One of those buckets is what I would call a popularized relevance algorithm. So this is something like signals boosting. So in the context here, say someone's running a search for iPad, and they get a whole bunch of search results back for iPad chargers and iPad dongles and just not great results because the search engine natively doesn't know what an iPad is and how to boost one, what's popular. So what you do with signals boosting is you take all the queries for iPad and then you see which results people are actually clicking on, purchasing, favoring. And then with enough signals, you can actually know exactly the right answer, not by doing some sophisticated machine learning algorithm, but literally by counting. You say, for this query, what are the top results people are purchasing that they want? And then you have your top page or two of results that you show to the user. The user's literally telling you, these are the results we want, the users, and then you show those results. And if you do anything more sophisticated than that to try to figure out what you should be showing your user, you're probably going to lose sales if you're in e-commerce. So that's signals boosting. It's popularized relevance. It's just looking at what the popular queries and popular items are for those queries and just using the data. So that's one level. Another level is personalized relevance. So that's what we were talking about a minute ago, whether you're generating recommendations, whether you're interleaving them in the results as recommendations, or whether you're actually taking the personalization vector that represents the user and using it to adjust the results. That's where you understand the user and then you cater the results to the specific user. And then a third category is what I call generalized relevance. And so this is your traditional learning to rank or machine learned ranking approaches, where you're taking lots of queries and lots of results, and you're either automatically learning from the signals a click model that you can use as implicit judgments to train your machine learning model, your learning to rank model, or you're getting explicit user judgments by having people annotate data. Either way, you build this model that takes lots of features. It looks at the judgments of query to document pairs, and then it learns which features matter in general across your domain. So the generalized relevance model is able to take queries it's never seen before and to apply a ranking algorithm to rank results based upon what features in documents and queries normally matter the most. And so I tend to layer these where there's actually one other category, which I'll briefly touch on, which is a semantic category where you can, semantic relevance, where you can learn from user behaviors. For example, somebody typed in the query manger. And usually after someone types in manger, they type another query that is manager. And so you learn that there's a misspelling, not from your content, but from actual user behavior. Every time somebody types in iPad with a misspelling, you correct it. So you learn what the synonyms to things are, what the acronyms for things are, what the misspellings are, and you can use that to help interpret queries as well. But if you just look at maybe the first three, if you think of ranking as not a pipeline, but as a sort of as a hierarchy, at your base level, you need some kind of a base matching. It can be, for lexical, it can be BM25 algorithm. For dense vector search, it can just be cosine or what have you. But you need like a base level ranking algorithm. And then on top of that, you have this generalized ranking algorithm, like a learning to rank model, a ranking classifier. On top of that, you can apply the signals boosting. And then on top of that, you can apply the personalized search. And some people will take all of these things and throw them in a pot, almost a witch's cauldron, and they just stir it up and they apply like XGBoost or some machine learning algorithm, and they say, whatever comes out is the magic potion. That's my ranking algorithm. You can do that, but there's things that if you keep them separate, there's ways that you can apply them in different ways. Or if we think of it almost like a pipeline, right? You can try something, see if there's results. If not, you try the next thing and you can put them together in different ways. So I tend to actually do the latter. It's a little bit more hands-on, but it gives you fine grained control over what you're going to apply when. If you want to turn something off, turn it on. Your one big model isn't overburdensome because you actually have all these knobs that you can tune. And so I tend to think of them as a stack and a set of techniques that you pick and choose when you want them. You can definitely combine them together, and you would do that in your generalized model and your ranking classifier. And there's other things like cross encoders, which are a form of ranking classifier we can talk about. But there's just all these different options. And my preference is not to just throw them in a cauldron and get a potion out. My preference is to intentionally analyze and use each one where it makes sense and to layer them appropriately.
Yeah. And this also gives you the capability to use query understanding in a much more sophisticated way in the end, that you actually have, based on the classifications you're doing, you have different pipes you're running through. For example, just for head queries, you might not even have to run like anything sophisticated. You just put it into a cache and just return whatever is in the cache, and that's it.
Your top most popular queries, you should already know the answer to those before you run them if you're not doing user personalization. But if you want to do user personalization, then, okay, that's going to change the dynamic. And maybe you start with those and then personalize those. Also with personalization, I mentioned earlier, you want to have a kind of a light touch. If you over personalize, people get really frustrated. So usually when I personalize results, I don't personalize all the results. I'll take the first page of results and I maybe personalize the second result and maybe the fourth and fifth result, and then I leave the rest of the page alone. Why? Because I'm hopeful that my algorithm for understanding user intent is really good, and they're going to see the second, fourth, and fifth result, which are usually above the fold, and be like, oh, hey, that's the thing I wanted. This engine seems like it's really smart. It knows about me. But if I'm wrong and the whole page is Hello Kitty microwaves and things I'm not looking for, then the user is going to leave and be frustrated and potentially never come back. So I think for something like personalization, it's useful to keep the algorithm on the side a little bit and use it to interleave results as opposed to having it take over as a core piece of the overall ranking system, if that makes sense.
Yeah. And when you actually think about this, like, what are the key components, especially in code, that you're setting up to implement this? Because when you don't do this carefully, it's like just a jumble of if, else, or case switch conditions, which basically pipe the user request into a certain direction. What's your technological setup to actually keep this into structured and understandable way that also allows you to figure out like where the mistakes are in your different pipelines?
Yeah, so the answer is it depends and it varies based upon the technology stack people are using, what have you. But I'll tell you my go-to, and a lot of this is in the book as well. I tend to take a query when it comes in. I'm going to ignore document understanding for a second, but in terms of query understanding, I tend to take a query when it comes in and have a knowledge graph of known entities, known things in my domain. So I mentioned a query earlier. It was like top barbecue in Atlanta or something like that. What I'll do is I'll take the query in, and the very first thing I'll do is I'll take it and I'll pass it to an entity extractor, but where the entity extractor has my knowledge graph in it. So I'll say, hey, do I know what the word top means? Oh, actually, yes. I've got something in my system called a semantic function. And a semantic function says the word top means, in the context of a restaurant search, popular restaurant. So what does that mean? It means 5 stars, or the higher the stars, the better. And so my system will say, oh, top is a known word in my domain understanding context, in my knowledge graph. It's a known word that is going to change how I interpret this query. And so from that point on, down the line, when this final query goes to the search engine, I'm not searching for some embedding vector that roughly corresponds with some semantic notion of what the word popularity means. No, I'm searching for boost my results by the number of stars, because the user wants popular restaurants, right? So that's what top means. When I go to barbecue, okay, this is a word. It's not in my knowledge graph. I don't really know what it means. So then I'm going to actually go to something like, so I've got something in the book I talk about, which is a semantic knowledge graph, which actually just uses the index to say, hey, what are the other most semantically related words to this? And it brings back things like barbecue, brisket, pork, ribs, things like that. But it can also bring back a category of, hey, the category is barbecue restaurant or southern restaurant or something like that, or home cooking or whatever the category might be. And so it can both boost the category and or filter the category as well as expand the term. So that's a sparse lexical expansion. It's similar to what you would get with something like splayed or similar techniques. You could use splayed for that piece. You could say, hey, I don't know what barbecue is. Let me go ask splayed. Then let me expand here to a splayed field, if you know what splayed is, to the listeners. So you could do that there. And then when I go to near Atlanta, same thing. Near is a semantic function. That means that if the thing after it is a city, then get the lat long and do a radius search for however many kilometers around the city, say 50 kilometers. And then my query to the engine actually becomes, at no embeddings whatsoever necessarily, it becomes an interpretation of that query that explicitly maps to a 50-kilometer radius near Atlanta, boost the most popular restaurants, find restaurants that have the word barbecue or are in this category of things related to barbecue, and here's some other related terms. And that will get you a very tight, data in your index specific answer that almost perfectly expresses the meaning of the user, as opposed to, let me take top barbecue near Atlanta, pass it to a transformer encoder, and it's going to give me some semantic understanding of popular things and things having to do with Atlanta, which would include the Atlanta Hawks, which would include the location, it's going to understand what you're asking, but it's not going to be able to get the right results from your search engine unless it's been very explicitly trained on how to query your search engine to get those results, if that makes sense. And so I want to say it's a next level above LLMs. It's not, it's just a different approach to try to focus on getting the user intent. So to answer your question about the tech stack, at any point where I was interpreting barbecue and getting that sparse lexical vector, I could also do a dense vector there. I could take the word barbecue and expand that into a dense vector representation for an embedding and do that as part of my search. I could, at any point in here, I can go back and forth between sparse lexical and dense vector capabilities. But your question was like the tooling and how do you do this stuff? And my answer is, I've got my knowledge graph. I have an ability to interpret the query based upon the knowledge graph. And then whether I use dense vector embeddings, sparse vector embeddings, or some other interpretation technique, they're all just tools in my tool belt that you can apply to the problem at hand.
Yeah, and I'm really interested architecturally, the personalization component. You retrieve the different user behavior vectors in the end based on a user ID. How do you use those, especially in light on the clustering we mentioned before as well, where you retrieve those and then you have the query, and how do you filter out what user behavior vectors to actually ignore?
Sure. Okay, let's go back to the microwave Hello Kitty example from earlier. Walk through it. So a user comes in, they've run a bunch of searches. I forget what I said, like Hello Kitty, plush toy or water bottle, a white GE electric razor, handful of other things. And then they search for a stainless steel GE range. And so now they come and they run a search for microwave. So the question is, okay, we could just do content context. We could just run a keyword search and find all the microwaves. Or we could try to understand what a microwave means in the context of my domain and filter down to appliances so that I'm not seeing microwave cleaning kits. I'm only seeing actual microwaves. I could do that. That's more of a semantic search, right? Or I can take the personalization context, which is what you asked about. So what I would do in this case too, I would do both of the first two, but I would also, for the personalization piece of it, I would go in, I would say, okay, I've got a query for microwave. Let me take that and pass that to assuming I'm doing a dense vector representation here, let me pass that to my transformer. I'm going to get an encoded version of this as a dense vector. And with that dense vector, I'm now going to figure out so I've previously clustered all of my products and I've got 100 clusters. I'm going to now find the nearest neighbor to this vector in vector space. And I'm going to say, oh, hey, the nearest neighbor is, I'm going to make this up, a kitchen appliances. Great. So found that. And then I might use that, or I might say, hey, actually find me my other four more around that. So I'm getting my top 5 nearest neighbors to the microwave embedding. So I might get kitchen appliances small, kitchen appliances large, household appliances, whatever those clusters are, right? So that will make up the sphere of what I care about. And then to personalize, I go to either my service or wherever I'm storing my user behaviors, right? All their signals. I then go say, get me the list of signals. Maybe it's 1, maybe it's 100, maybe it's 1,000, whatever the previous user behaviors are. Just filter those down to these clusters. And then now maybe down to 5 or 6 or a smaller number of behaviors. Those behaviors, which in this case I'm representing as vectors, each of those the vectors representing the items that have been interacted with, I can then take those and say, these are the relevant behaviors that on behalf of the user, we think the user would care to be considered in the context of this personalization, context of this one query. So I take all of those and they all have to do with kitchen appliances. And I say, all right, let me average these together and get a personalization vector that represents the user. It's like a user profile, but it's contextualized to that one query that they're running right now. And then I say, okay, let me take that. And within the context of this vector, I probably have things represented like stainless steel, maybe a price range if they looked at things within a certain price range, maybe a brand, GE, if GE is somehow represented in my embedding. And so all of those concepts based upon their past behavior get bubbled up in this personalization embedding. And then I apply that as part of my query to boost results up or down, or potentially just to run a separate personalization query and interleave like I talked about. So that would be the general flow for how I would go from users typing a query now to getting their contextualized behaviors brought back. That would be the flow.
That's so interesting. I want to touch quickly on the different search engines, especially like OpenSearch, Elastic, Solr, and Vespa.
Sure.
What are like the scenarios where you really would say you would pick one over the other? I'm not interested in exact trade-offs, but rather what are scenarios where one really shines?
Yeah. So I'll preface this with saying I like them all and try to be generally vendor neutral. I do search consulting and happy to work with anybody working on any of them. But it's interesting. I'm going to be a little PC on this answer, so sorry. So I told you I got started with Solr. I love Solr. Solar's near and dear to my heart. It's an Apache Software Foundation project. It's great. It doesn't have the commercial backing that the rest of them do. And so the development and upkeep, I would say, is slower than I would like. And so I definitely see some of the other engines surpassing it. But it's the default in my book I'm actually using. So the book's got Solr, OpenSearch, and others that you can use with the book. But it's near and dear to my heart. But depending upon what you're looking for, there might be other technologies that either are faster, have some capabilities, things like that. So Elasticsearch came about to replace Solr. They took a lot of market share, a lot of really good technology there. They had issues with licensing where they went non-open source for a while. Now they're technically open source. The license is not my favorite license, but as a result of that, Amazon forks Elasticsearch and has OpenSearch. At this point, I would say not enough time has gone on that I would draw a clear differentiating line between Elasticsearch and OpenSearch. Is doing some new things. Elasticsearch is doing some new things, and both are really cool. So I think both are great projects. I like the governance model of OpenSearch better. They've got the OpenSearch Foundation as part of the Linux Foundation. I love open source. I just feel confident about it. But Elasticsearch has great technology. They've got great engineers, really smart people, and they do good work. And so if you're in their ecosystem, in their sphere, like I think you can't go wrong with any of them. Vespa was an interesting one because they've been around for probably the longest of any of them because they were the Yahoo search engine, but they were internal in Yahoo. Then they split out. There's like Verizon Media, all that kind of stuff. But they split out. Then it became an open source company project, and then they became an open source company, and then they raised a bunch of VC capital. And so I look at Vespa and what I generally see in terms of my work with it and in terms of implementation is it's like everything in the kitchen sink. It's very powerful. It was written by people who are very smart and think about search in a very, I don't want to say correct way, but like it's very clear that they're somewhat visionary in terms of how they've designed it. But it's also intimidating. When people go to try to get started with Vespa, they're like, I'm talking in the terminology of vectors and dimensions. And it's like from day one, there's like a learning curve to get over. And so what I tend to see is people who hit a limit with some of the other engines will go to Vespa because they're like, hey, I need all this power and it's worth the learning curve. And people who are trying to approach search, not maybe without as much sophistication, just might be scared of it because it's a lot. And that's not to say that Vespa is the best at all things, because it's not. It's just to say that it's very capable and it's getting more approachable over time. But I think, at least in my circles, I think Vespa is very powerful and to the point where it intimidates some people. And I think that'll change over time, I'm sure. But hopefully I'm not saying anything that anybody would disagree with or be offended by. But they all have their place and they're all really good. And they also all, I should mention, leverage each other as competition to get better. Vespa is focused on getting simpler. I'm going to say the open search pressure forced them to go back to open source. Maybe they would claim there's other reasons, but either way, Solr, when Elastic came about, changed a lot of its architecture to meet the demand. So I think it's really good to have a lot of options. It's really good to have competition. And I think everyone can see their strengths and their weaknesses and try to minimize weaknesses and focus on strengths. But they're all great. I recommend all of them for a project, depending on the project and what your needs are. No bias towards any one particular. Sorry.
And what are the most exciting or promising things on the horizon for AI-powered search?
The most promising things on the horizon. Oh, man, there's so many things. I write about a lot in the book, and I think that my message to people, whether you're getting into search afresh because of generative AI, whether you've been here for a while and you're trying to get more of the AI aspects, is there's a wide spectrum of tools and techniques and approaches, many of which we've talked about today. And it's really useful to familiarize yourself with them and try to apply them where it makes sense and just to know what's possible and then how to do it. So the starting point is there's a lot of unexplored territory that most people just need to explore. But beyond that, in terms of the future, I'm really excited about a couple of things. One is these late interaction models like Colbert, Colpally, where it's funny. So that's one of the. We've gone from a bag of words and a bunch of keywords, and I'm matching on each keyword and then adding up how well each of my keywords matched and we shifted the pendulum to, hey, let's just take the whole document and turn it into one embedding that represents the meaning of the entire document. And then we decided, oh, wait, actually, we're losing too much nuance from the documents. Let's shift back now and let's start chunking document. This sentence gets an embedding and this sentence gets an embedding in this sentence. And then we're like, now each sentence doesn't have the context of the whole document or around it. So now let's contextualize the sentences. So we started overlapping chunks and taking chunks and doing contextualized embeddings where I take an embedding of the document and an embedding of the sentence and I combine them together to have the sentence and the context of the document. We're doing all these weird amalgamations of trying to split apart the document in some kind of semantic chunks. And it works, but it's a lot of pain and it's a lot. What I like about something like Colbert and this late interaction model is it goes back almost to the original idea of mashing on individual keywords, but it does it with embeddings. So it goes through a document and says, every keyword in this document, I'm going to create an embedding for. Similar to what we used to do with Word2Vec back in the day. Every word has an embedding, but unlike Word2Vec, which always has the same meaning of every word and it's not contextualized by surrounding words, with Colbert, we give each word a contextualized meaning based upon the context surrounding it in the rest of the document. So each word gets its own contextualized embedding based upon its particular meaning and interpretation there. We do the same thing with the query. So the query comes in, we take each individual query word, we generate embeddings, but what we can then do is we take all of the embeddings, all the words in the query and all the words in the document, represent them as embeddings, and then compare the similarity of each of those embeddings as we go. And then just take, for each word in the query, we take the maximum score of any word in the document, and then we can add those together. But it's not complicated at all, but it does take a lot of extra storage to store that many embeddings. But what it does is it allows us to go back to, I'm matching on keywords again. I'm matching and ranking on keywords, but I'm interpreting the meaning of those keywords based upon the semantic context around it, as opposed to just, is this string there or is it not, which is what we did with traditional Boolean matching in BM25. And those models are vastly outperforming these other approaches that we're trying. And when you look at Cole-Pally versus all the OCR stuff that we talked about before, it's massively outperforming what was there before. So I think just, not that we're getting back to the roots, because this is a new technique, but this notion of thinking of words as contexts of meaning, it is like clusters of meaning and that have some context, and matching on the clusters of meaning and how they combine, I think is core to what it means to interpret language. And I like that these new approaches are, I think, more appropriately focused on interpreting language as opposed to just using an embedding model and expecting magic to happen.
Yeah. And if people want to start building the stuff we talked about, what are, in your opinion, the best resources out there? And I'm already going to say your book is probably the best one I've found so far, so I'm going to throw that in there. Okay. So maybe shout out like where people can find that.
Yeah. For the book? Yeah, so it's Manning is the publisher. So if you go to aipoweredsearch.com, you can buy the book. Also, it hasn't launched yet because the book's literally gone to the presses, and probably a couple of weeks and you'll have it in your hand if you've bought it. But we also have a website launching for it. And part of that website is actually a community. One thing I'm trying to do is make the book not just a book, but also to create it as a resource, to have a website and a community where people can join and actually have discussions and talk and interact and discuss the latest and greatest in the forefront of AI-powered search. And so we've got maybe 400 people, members who've joined already, mostly search experts and people from conferences and things like that. But in terms of resources, the book is a key one, the website, but I'm trying to create a larger community around AI-powered search, the concepts in the book, and really promote the companies and the people in the space. I'm hoping that will be one of the best resources in our field for this going forward. But otherwise, yeah, I'll shout out to all the companies in the space who are doing massive evangelism. All of them do it. OpenSearch, Weaviate, Vespa, everybody. I would say that if I look at the quality of the content coming out of, or at least the amount of really smart people who are trying to explain this to people, companies like Weaviate do a really good job with their evangelism. Vespa, I think you had Joe on your podcast recently. He's super bright, does a great job with evangelism as well. There's so many people from all of these companies. I shouldn't probably be calling out specific names because there's so many. But I hope that with the book and with the website, we can actually pull a lot of these people in and try to like cross-post and share a lot of this content to just really get it out there. Because there are a lot of people who are trying to get into search, get into retrieval, and try to understand it. And the resources are out there, but they're definitely spread across, everywhere, different companies, blogs and YouTube channels. And I think that having a resource where we can pull it together and share will be really helpful.
Nice. And I will put all of that in the show notes. If people want to follow with you personally, where would you point them?
Twitter, LinkedIn, Trey Grainger. I've got a company called Search Kernel. I'm going to be hanging out in the AI-powered community. So if you go to community.aipoweredsearch, all one word.com, you can pretty much catch me there anytime if you want to ask questions or hang out. That's where I would go.
So what can we take away when we are building search applications? First of all, RAG is not just a vector search. You want to build RAG as a continuous feedback loop. So generative AI helps to interpret queries and summarize results, and also add, for example, metadata filters to improve the search results. The retrieval provides up-to-date and accurate information to generate better results. So each component enhances each other, and we can even loop. We can do like agentic RAG where we ask the LLM whether we have enough results and basically run a new retrieval with a newly or generated query or just an adjusted query. And through that, we have like way more capabilities than this only vector search component. And then we can basically layer additional search techniques on top. Like, for example, a traditional lexical search or more personalization through personalization vectors and stuff like that. So we basically build a pipeline. So first, like basically query understanding, you interpret the query, you classify the intent, you extract entities, you extract filters. So for example, time filters are a very common one. Then you retrieve, you use multiple retrieval strategies, you use keyword search, you use vector search, and then you basically combine them, you fuse them and re-rank and add domain-specific filters. So here you could place your knowledge graph. And lastly, you enhance the results with LLMs. You can summarize them, you can gather additional context, you can generate follow-up questions, and then lastly you have like the iterative refinement, like a loop. You don't have an adequate answer to the user query, or you don't have enough results or enough good results that you can actually answer a query. You reformulate it and you run an additional retrieval, or if it's enough, you generate a final response. And I think this is a really interesting like architecture pattern, because it creates components, it creates a separation of concerns, and you can also decide, okay, what is actually necessary. I think Trey showed like the different architectural components and how you could combine them. And for you, what's most likely is interesting is like picking a few which you think bring the biggest bang for your buck and just implementing those, and which are actually most suited for your use case. So for example, in e-commerce, you might not want to use like this iterative refinement or like really expensive result enhancement. Also, you won't use it because it will add too much latency. So you take the components that actually suit your use case and you build a pipeline like that. And I think like having an overview of all the different things you could do and for what they are well suited is really interesting. And this really leads into like his 3 critical context frameworks, which help you actually decide, okay, in my type of search system I'm building, what is actually relevant? Because his 3 contexts, like to summarize again or paraphrase, you have content, you have user, and you have the domain. The content basically is the raw document processing. The user context is the behavioral patterns and preferences. The domain context is like the business and domain specific knowledge. And for business and domain specific, there might be a mismatch. What is business and domain specific for your user and for your company? And then you basically have the implementation of these different contexts, like for content, vector embedding, keyword indexes, document structure understanding, for user, click tracking, query logging, purchase, interaction history, session behavior, user clusters, for domain context, knowledge graphs, entity relations, business rules, taxonomy, semantic functions. And you basically have these different technologies and basically like a tool set. And then you look at your search application and look at especially like, okay, what's going wrong? Like my users in the front end are not really clicking the results, but where is it coming from? Am I serving inadequate result? Like, is the content actually bad? Then I might have to fix my content. Is it not personalized enough? Then I have to improve the user context and basically treat it as a grab bag of different techniques that you can layer with each other to find a solution. And in most cases, it won't be like one or the other, but a combination of those. So you need to combine them in the end to build like a complete search system, but you always fix the biggest issue first, like where it's burning the most. Is your content garbage, your search garbage, or is the personalization garbage? Pick this, fix it, go to the next. And this is like one of the things he mentioned he often sees when people do this is like this witch's cauldron anti-pattern, which is that people are using like one monolithic ranking model. So you take whatever signal you find, like BM25, vector similarity, popular items, click-through rates, conversion signals, user preferences, recent behavior of the users. You take all of it and slap it into like a massive model and basically hope something good comes out of it. And it's all good and well if it works, congrats. But if it doesn't work, you will have like a lot of troubles because you can't debug it, and you will need to retrain the entire model from scratch to actually try to fix it. So your iteration loops are way longer. So instead, you shouldn't throw everything together in one pot, but rather separate the different components. Find smaller little fixes and componentize it. Like, this is also like, it's really software engineering-esque that you want to separate the different components, isolate them so you can easily trace bugs, you can tune them in isolation, and you can easily A/B test adjustments, and also make it easier to maintain because you can change a singular system or a singular component. And he really advocated this like layered architecture with the different signals, which can be turned off and on, which is something I found really interesting. So you basically have that base layer, which is always on, like BM25 and vector similarity search, which does like this basic relevance scoring. These are like your core matching criteria. Then you have like the middle layer, which is more like a signal boosting, which could be like popular items, click-through rates, conversion signals, historical performance as well. And then you have like the top layer, which is more like the personalization part. So user preferences, recent behavior, category affinities, or the positions. And you keep these independent and can then switch them on, switch them off, also on the query type, and use them together, isolate them, and you really can see, okay, where are my results coming from? I have basically in my result set I delivered to my users, like he clicked on one of the bottom ones. So I got them out of the base layer, but my personalization layer or my signal boosting layer basically downranked it. So basically you can see, okay, where might my issue be coming from? And then you can tune the component which actually was in the wrong. And one more part in that is basically the smart personalization. This technique he mentioned is basically the user behavior clustering, where you can create different category clusters and map user interactions to the clusters. I think this was a really interesting approach. I think I need to try to code it up to really understand it, but this could be something really interesting and something pretty easy to implement. And maybe to note last, I think we already went a bunch into that, like modern search systems, like where it is evolving, and we are really getting into like a more contextual understanding with, for example, cold poly, but also cold bird, where we have like word level or image patch level understanding, and we have embeddings for each, and we can maintain word relationships. And also we can trace back, okay, where might it be coming from and why is it relevant? And this is much more compute intensive, but also leads to way better results. And I think we will see more and more of that, especially as the technologies are getting better to actually deploy them. And this could also mean that we might get away with worse retrieval systems, but with more powerful re-ranking systems. I think this really fits into the general theme of generative AI, where we have more inference time compute. And so we over search, so basically we retrieve a lot of documents and then we run them through a re-ranking system. And when it's efficient and fast enough, we might actually get very decent results or way better results than we do currently when we are just using semantic search. Yeah, that's it. I will stop talking now. I think this is already the longest episode we had. I really can only endorse buying the book from Trey. I think I read it twice right now, once when I bought it and once when I got Trey on as a guest. It came out a few weeks ago, like the final version. And get it. I think it's available everywhere. Also join Trey's community, Airport Search. I'm also in there if you want to chat. Otherwise, we will be continuing our search next week. And always like, subscribe. It helps a lot. Leave a comment, especially on the podcasting platforms. Otherwise, I will see you next week and see you soon.